Okay. We could definitely do a slope field for this, right? We could plug in different values of x, y, figure out the slope at that point, do a little tangent line there at that slope, do a bunch of them, and I get a visual of possible solution sets, okay? But if I can separate it into a function of x and a function of y, I'm gonna show you that not only could I do a slope field and give you a whole picture of possible answers, I might give you an equation for the answer, okay? If I can separate it into a function of x and a function of y. Oh, I gave everybody answers. Okay, so here's what we're gonna try to do. See if we can write an equation with all the y's on one side and all the x's on the other side. Put all the y's on one side, all the x's on the other. If I can do that, then I can take the integral of both sides. I will show you why. That's what we're gonna do. Just keeping the words in your head. I don't know. So let's just show you what we're gonna do. Okay. So if we go all the way down here. And here's some examples here if you want to look at some of college boards, how they do it. I assign those two. Look where we are now. Way up inside. We're almost done. Okay. So look at this. And I would grant you that we almost did a slope field that looked like this. Right? We did an XY table that looked pretty similar to that. Because we were saying, hey, I couldn't get the solution. What am I gonna do here? Okay. Let's see if I can get all the x's on one side, all the y's on the other. Hey, what if I multiply both sides by y squared and I get y squared dy? And then I multiply both sides by dx and I get that equals x squared dx. I am able to get all the y's on one side, all the x's on the other. So what do I do now? Let's integrate both sides. Integrate y squared dy equal, integrate, whatever you do to one side, you gotta do the other, integrate x squared dx. We can do that, can't we? Okay. What's this gonna be?
Y third over 3.
Yeah. Y to the third over 3, or if you want to call it 1/3, y to the third. Not a definite integral. We want to say equals. Well, that's going to be the same thing, just in terms of x, right? 1/3 x to the third plus another c. Hey, I got a c on one side, c on the other side. What we're going to try to do is isolate the y. What I could do is multiply by 3. And so I get y cubed plus 3c, 1. Those don't have to be the same constant. X cubed plus 3c2. Then I have y cubed equals x cubed plus 3c2 minus 3c1. You know what I'm going to do? This is some constant minus some constant. Isn't that just going to be a constant?
Yeah.
Can I just call that just this? Maybe one's 5 and one is 7. I put them together, I still get a constant. Some constant. And can I take the cube root of both sides? got a solution. Not only can I do a slope field, sometimes I can give you a solution. Questions? Okay, find the solution of this equation that satisfies the initial condition, y of 0. That's what this one is, I'll just show it up here. I know when y of 0, what did I say, equals 2. Does anybody know what that might be?
Like the final answer.
Yeah, because if x is 0,
What's he is?
Is it 8?
yeah. So y of 0, 2 would have to equal the cube root of x is 0, 0 cubed plus c. So basically the cube root of some number has to equal 2. And if I raise each to the 3rd power to get rid of the radical, c would have to be 8. So my particular solution, if I have enough information, would be y equals the cube root of x cubed plus c. So remember, sometimes on the slope field, we have a particular point and we're trying to sketch the one that goes through that point. Of all the ones on the slope field, sketch the one that goes through that point. I can give you maybe the exact equation, if I can separate the variables. I'm not saying you can always do that. So slope fields can give me a whole family of possible solutions. And if I can separate the variables, I might actually be able to get an equation. Questions?
So basically, would you do like this type of method if you have x and y on the same side?
Either way, any way I can get all the x's on one side and all the y's on one side.
Okay.
They don't have to start out being on the same side. If there's some way I can get all the x's on one side and all the y's on the other, I might be able to do it. Although our next one, yeah, they are on the same side. But let's see if I can separate those. Okay, what have we got? We got that. I wonder if I can get the x's and the y's on the same side. Yeah, I'm going to scroll down a little bit because I don't want to distract with number 3. Yeah. Hey, I can kind of do the same thing I just did, can't I? You multiply this denominator, because it's all y's, move that over here. 2y plus cosine y with the dy, and multiply this over here, because the numerator is all x's. 6x squared dx. And then once I've done that, I can probably integrate both sides. Of course, one side I'll integrate in terms of y and one in terms of x. So if you want to, these are two different terms. We know we can do this, if it helps. So I can break it up into two terms and do the integral of 2y dy plus the integral of cosine y dy. And then over here, if you want to bring that 6 out, integral x squared dx. Which means you could probably bring the 2 out over here also. And then what do we have over here?
Y squared.
Y squared over 2 with the 2 in front,
But the
which
2
would just be
cancels out,
y
so it's just y
squared.
squared.
Right, y squared over 2 with that 2 in front, they would cancel. Plus c, but I know I'm gonna have a lot of plus c's that are gonna end up adding or subtracting together. I'll just wait and do that plus c at the end. Hey, what's that? Integral of cosine.
Sine.
Minus, right?
Negative sign.
Is
No, it's
Meant to
plus
say,
sign.
yeah, I
Yeah,
thought it
you're
was-
right. Of y. Plus c, but we're gonna do the plus c at the end, because we're gonna get a constant somewhere. And then over here, I've got,
2x to the 3.
yeah, x to the third over 3 with a 6 out front, 2x to the third, plus my c. Now I can do my c. There's gonna be multiple constants that are gonna come together to create a constant. Isolate the y. I don't know if I can here.
There's 2.
Yeah, I don't know if I can necessarily isolate the y here. So I would say, yeah, that's as good as I can get. I'm not sure I can make that any better.
Wouldn't there be a plus c on the other side? But
There would be, but you would move it over here.
Yeah, but then what if we know which c is bigger than the other?
Doesn't matter, because the c could be negative, I don't know. Yeah, it's just something without a variable on it. And I'm gonna combine all my constants to create a constant, whether it's positive, negative, integer, rational, irrational. I'm gonna have a constant in here somewhere. Do another one?
Yeah.
Okay. I say after number 3, you may wanna start something. And then I can say 4 and 5. Yeah, I'll say 4 and 5. So I'm gonna have enough room. That should be. Okay, we're gonna try to solve this one. We got y prime. Can't I just rewrite? Did y'all see the prime in there? I realize it's kind of small. There is a prime symbol there.
dy dx.
So that's basically dy dx, right? Which equals x squared y. Okay. If I want to get all the y's together, I'd have to move this over here, which I can divide by the y, 1 over y. And then multiply the dx over here with the x squared, that would be x squared dx. If I can get all the y's on one side and all the x's on the other side, then I can just integrate in terms of equal variables. What's the integral of 1 over y?
ln.
Natural log. Plus some constant. We'll say that for the end. And that's gonna be x cubed over 3? Or 1/3 x. Whatever you wanna do, 1/3, what, do you prefer 1/3 x cubed or x cubed over 3?
X cubed over 2.
X cubed. And I would have done a plus C here and a plus C here, and I'd wanna get my constants together, which would create another constant. There's a constant. Here's my question to you. I couldn't really isolate my y in, what was it, number 2. Can I isolate the y here? I can. Yes, I can. We gotta remember what a log is saying.
Yikes.
E raised to some power equals this. E raised to this power and technically the integral of this is absolute value. So if you plug in negative values, it becomes positive. And there is, hey, when I'm adding two exponents, doesn't that mean I'm multiplying with the same base? Because I would just be adding the exponents. I don't know which ones. I don't know which one you like better. Do you want the one base with the two added together? I don't know. Whichever one you like. I can tell you this, looking at a slope field, I would not have guessed this would have been a solution. But by separating the variables, I can tell you that could be a solution. And if you give me a point it goes through, I could tell you what that is and give you the exact solution. I think that's good for today. We know what it is. We'll do a couple more. 4 and 5, they'll be quick, but I know you're biting at the bit to start some separation.